All right, let's get started with our pre-algebra course challenge. So for the first question in this exam, we have Thomas needs exactly 6 potatoes to make 12 potato pancakes. Which of the following statements are true? Tom needs exactly 12 potatoes to make. Okay, so I can see that the ratio between the potato that Thomas needs and that of making potato pancakes is 1 is to 2, because if we have 6 then 12, so 12 divided by 6 is 2. So for each, for with one potatoes he can make 2 potato pancakes. So we'll have to select all the options that follows this ratio. So 12 needs exactly 12 potatoes to make 24 potato pancakes. Yes, this is in line. And 18 2s are 36, so this is also in line. 18 times 2 is 36, so this is also good, but not this one is not good because 24 times 2 is 48. This is good. 30 times 2 is 60, but 36 times 2 is not 78. 36 times 2 is 72. So we select A, B, and D for these for this question. A, B, and D. All right. Which equation best shows that 55 is a multiple of 11? So if 55 is a multiple of 11, then 11 times something should be equal to 55. So which is shown here. 11 times 5 equals 55. This is the best equation that we can select. All right, solve for n. So in order to solve for n, what we need to do is we have to make the power equal, exponent equal, such that we can equal the base. So we know that if we take this bracket out, then we have to add the power, multiply the power. So 7 over 4 to the 8 equals n to the power 8. Now because the power or the exponents are same, we can equate the base. So n equals 7. All right. So for the next question, two stoves were turned off at the same time and they both started to cool down. The following equation gives the temperature of the first stove in degrees Celsius and as a function of time in minutes. The graph of the temperature of the second stove in degrees as a function of time is shown below. Here is it. Okay, fine. Which stove has a higher temperature? Which stove started at a higher temperature? Which means when we have m equals to 0 at the beginning, for this one, we have 180 degrees Celsius. And this one, we have 200 degrees Celsius when m equals 0. So definitely the second stove. Which stove cooled down at a greater rate? This refers to the gradient or the slope, the change in temperature per unit minute, per unit time, that is meant per minute. So here it's negative 1.55, and we have to calculate the gradient for this one. So in order to do so, I'll take 2 points. So first one is this thing, 200, and let's say I choose I don't know, this one. So this thing, so each box, one, two, three, four. So four boxes, one, two, three, four, correspond to an increase in 40, 130, 140, 150, 160. So each boxes represents 10 units. So it's 130. So 200 minus 130, 200 the minus 130, the change in y over change in x, which is 200 is at 0, minus what happens when it's 130? It's 40. So let's plug in 40. Oops, 40. So it's negative 1.75. Negative 1.75 is the um, slope, or the the rate, the slope, the rate at which it is cooling down. So which stove cooled down at a greater rate? Well, this one is 1.55 and this one is 1.75. So it's the second stove you have to get. There we go. All right, complete the table for the given rule. Rule is y equals to x minus 3. Okay, So if you want to get y, we have to subtract 3 from x. So 7 minus 3 is 4. And now we have to do the opposite thing. If you want to get x, then you'll have to add 3 to y. So x equals to y plus 3. So this thing is 4, this thing is 10. All right. Find the solutions of the following equation. So we have to find the solution for a. We know that this is because this is square root. This is square. If we root both sides, then we have a plus minus root 64 by 225. So root 64 by 225, let's see what that is. Root 64 divided by 225. Okay, so it is 8 upon 15. Okay, so plus minus 8 upon 15. So these two should be our answer. There we go. All right, the Mississippi River flows at a rate of this 16,790 cubic meters per second. Choose the best approximation of the flow rate of the Mississippi River. Okay, so we have they're rounding out. They're rounding out to one decimal, one significant figure. That's good too. Now, whether we have 10 to the power 3 or 10 to the power 4, well, if this is 2, then 1, 2, 3, 4. We have to choose B because there are 4 digits after 2. The Gulf of Mexico has an estimated volume of this thing, which is the best approximation. So if you select the first thing again, you have to count how many digits are there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So why 12? It must be 15. Approximately how many seconds would it take for the Mississippi River to fill the volume of Gulf of Mexico? So the volume is 2 into 10 to the power 15. So we have to divide this thing with this. So 10 to the power 15 divided by 10 to the power 4, 10 to the power 15 divided by 10 to the power 4. It is 10 to the power 11. So C is our answer. All right, simplify to create an equivalent expression. So let's simplify it together. So if I take out the bracket, we have negative y, and then the negative sign is there. So we just multiply everything with 3. So negative 9y plus 5, 3, 0, 15. Now we take out the negative. So negative y, positive 9y, negative 15. So 9 minus y is 8y, positive 8y, negative 15. So D matches with my work. While exploring a volcano, Zane heard some rumblings, so he decided to climb up out of there as quickly as he could. All right, Zane or Zani's elevation relative to the edge of the inside of the volcano in meters as a function of time in seconds is graphed here. How high did Zane climb every 7 seconds? So here they're referring to, first of all, we need to find the gradient. How high did Zane or Zani climb every second? And then we have to multiply the gradient with 7. So let's figure out the gradient. All right, we'll take 2 points, this one and this one. Okay, so gradient or the slope is the change in y over change in x. So let's say I take this one as y1, this one to be y2 or 0.2. So y2 minus y1, negative 25 minus 0, x2, which is this thing, 0 minus x1, which is 35. So what do we have? This is 0, nothing. Yeah, negative, negative cancel out. So we have 25 over 35. So 25 over 35. We have a positive gradient of 5 by 7. Now, 5 by 7 is the slope. This is the change in elevation per second. So every 7 seconds, it would be 5. So 5 meters. A is our answer. All right, match each expression to its expanded form. So 3 to the power 4 means we are multiplying 3 4 times. This is this. 4 cubed is multiplying 4 3 times. Is already this thing. 4 into 3 means that No, this is not. This is 4 into 4. It's the same as adding 4 times 4, and 4 into 3 means you're you can yeah, you can represent like this. You can add 3 4 times. You can either add 4 3 times, or you can add 3 4 times. So correct. Choose the inequality that represents the following equation. It's an open circle, so that is less than and greater than, not equal to. So it's in line with this. So it's representing towards the left. So x is less than 3. So C is our answer. Which will describe the relation between x and y coordinates on the following graph. So it, as we can see, it's a positive gradient when we kind of draw this thing. It's a positive line. We can tell because the you know, the x, as x increases, y also increases. So x and y are following each other, the positive gradient. So um, so both of them shows positive, but where is the y-intercept? If we extrapolate this line and see, well, it is intersecting somewhere at 1. So this is the y-intercept. It's not intersecting at -1. So we select B. What is the prime factorization of 75? It returns as a product of the prime factors like 2 into 3 into, or a single prime number like 17. Okay, I'll select a product of prime numbers. What is the prime factorization of 17? So 75 is not divisible by 2, but it is divisible by 3. So 25, I can select as, I can write 75 as 3 into 25. Again, 25 is not divisible by 2, but it is divisible by 5, not divisible by 3 as well. So I can write 3 into 5 into 5. This is the product of prime factors. So let's write it down. 3 multiplied by 5 multiplied by 5. All right. Nikki shovels snow at a constant rate. Nikki plots points on the coordinate plane below to show how many scoops of snow they can shovel in different lengths of time. Which of the following ordered pairs could Nikki add to the graph? Okay, so in order to do so, we have to draw the line and see what trend it follows. Okay, to extrapolate up until this thing. So which of the following ordered pairs could Nikki add to the graph? 110, no. 110, yes, this is possible. 230, whoa, that is also possible, I guess. But which of the following ordered pairs could Nikki add to the graph? 685, 685. All right. So shovels snow at a constant rate. Nikki plots points on the coordinate plane below to show how many scoops of snow they can shovel in different lengths of time. So, which of the following ordered pairs could Nikki add to the graph? Is it 110? Is it 230? Is it 685? Okay, so I'll have to carefully draw the line again and see which one we could do it. Okay, so this thing goes here, here, and we have 1 2 3 units down, 1 unit left. 1 2 3 units down, 1 is left. So it's perfectly fitting here. 1 2 3 units down, 1 unit left. Okay, 110 is not okay, so we cross it out. Okay, as for this one, we have 1 2 3 units down, 1 is left. So this one is not okay as well. So we can only add 230. Wow, that was very close. So 230. All right, the table compares the size in grams of rice packs and their cost in dollars for several different convenience stores. Can the size of a pack be represented as a function of its price? Can the size of a pack, okay, size of a pack be represented as a function of its price? So we know that, the definition of a function, the function could be 1 to 1. That is not the problem. But a function could have the relationship of many to one, but it cannot have the relationship to one is too many. If it is, then this ceases to be a function. Examples are, uh, graphs like this, where you have multiple y values for the same values of x. So, can the size of a pack be represented as a function of its price? So, function of its price. So, function price equals size. This is what the question is stating. The size of the pack we represent as a function of its price. So this is x, this is y. So if we have to see whether for the same value of x we have multiple values of y or not. So let's say there is a repetition in y in the first place. There is repetition 850, 850. There we go. We have, but this is for the same value, so this is not the problem. And we have repetition for y, but we don't have, we have different okay, so we have to see whether for the same value of x we have different values of y or not. Okay, let's check it. For same value of x, whether we have different value of y or not. So first see, yes, we have 1.9 here. See, we have 1.9 here, and we also have 1.9 here. We have different values for the same value of x. So no, this cannot be represented as a function. In a certain card game, for every 4 blue cards, there are 3 yellow cards. There are a total of 84 blue cards and yellow cards in the game. How many blue cards are in the game? Okay, so what is the ratio? 4 is to 3. So if for every 4 blue cards we have 3 yellow cards, so the total is 7 parts. Okay, so if there are total 84 blue cards and yellow cards in the game, how many blue cards in the game? So the ratio for blue cards is 4 upon 7. Now the total is 84, so how many should be for blue cards? Let's check it out. 4 upon 7 into 84. 4 upon 7 times 84 is 48. It should be 48. All right, we have to evaluate the expression and we cannot round up our answer. So 6 plus 3 is 9, plus 1 is 10, 10 squared is 100, 100 divided by 4 is 25. All right, cube root of 723. Cube root of 720. Sorry, 729, 723. So this is the same as 729 to the power of 1 by 3, which is 9. Okay. We know 8 into 5 equals 40, which of the following statements are also true? So 8 is a factor of 40. Yes, it is. 5 is a multiple of 8. 5 is a factor. Okay, so you have to choose two answers. 8 into 5 equals 40. 8 is a factor of 40. 8 is a factor of 40, which means 40 divided by 8 should be, yes, it is. 5 is a multiple of 8. No, 5 is not a multiple of 8. 5 is a factor of 40 because when we divide 40 by 5, we have an integer. But if 5 is a multiple of 8, so 8, we should get 5 by multiplying anything with 8, and that is not the case. 8 0 is 0, 8 times 1 is 8, 8 times 2 is 16. We never get 5, so 5 cannot be a multiple of 8. So A and C is our answer. All right, so Molly and Tori like to eat ice cream sandwiches. In 1 week, Molly ate 5 ice cream sandwiches and Tori ate n ice cream sandwiches. They ate a total of 12 ice cream sandwiches altogether. Write an equation to describe the situation. So Mori, okay, so I don't know what variables to choose, but Molly and Tori like to eat ice cream sandwiches, and so Molly ate 5 ice cream sandwiches and Tori ate n. Okay, so that means 5 plus n would be equal to 12. So how many did Tori 8, so that is 7. 12 minus 5. Combine like times to simplify the expression. Enter any coefficients as simplified, proper or improper fractions or integers. All right. So 2, 5. Okay, so let's solve it together. So we have 2, 5, 2 upon 5 plus 1 upon 10. We can take k outside, minus 3 by 5. And we have to add this up, so we take LCM 10, we divide by 5, that is 2 into 2 plus 1 k negative 3 by 5, so that is 4 plus 5 1 5 by 10 k negative 3 by 5. We can cut it down to half, so half k negative 3 by 5. This should be our answer, half k negative 3 by 5. Right. Kermit's favorite iced tea uses 15 tea bags in every 2 liters of water. Okay, so 15 tea bags in every 2 liters of water. Okay, so which means what's the ratio? For like 15 divided by 2 is 7.5. So 15 divided by 2 tea bags for every liter of water. Peggy make a 12-liter batch of ice with 90 tea bags. Okay. So Peggy and Kermit keep the bags in the water in the same amount of time. What will Kermit think of Peggy's ice tea? Okay, let's figure out the ratio. So what Peggy is doing, 12-liter batch of iced tea with 90 tea bags. So for each liter, it would be 90 divided by 12. So the Kermit one is 7.5. So so 15 divided by 2 is 7.5. But for the Peggy's one, it is 90 divided by 12. So 90 divided by 12, 7.5. It's the same thing. So Peggy's eyes is just right. Two rules for creating a pattern are given below. Each rule begins with a number called the input and creates a number called the output. Rule 1 is subtract 8 from the input to get to the output. Rule 2, divide the number by 3 to get to the output. Which input and output table works for both values? So we have to subtract 8 from the input. So 18 minus 8 is 10. It doesn't. 12 minus 8 is 4. It does. Divide 3. 12 divided by 3 is 4. So B is the answer. The tape diagram represents an equation. Write an equation to represent the image. So we have 1, 2, 3, 4, 5, 6. 6 times t being equal to 9. Okay, that is our equation. Rearrange the equation so that a is the independent variable. All right, a is the independent variable, which means we have to make b the subject. So 3a negative 7 negative 1 equals negative 4b. We're adding subtracting negative 1 from both sides. So we have 3a negative 8 equals negative 4b. So if we make b the subject here, it is equals to 3a negative 8 over negative 4. Okay, so if we take this negative in the numerator, we have b equals to 8 minus 3a divided by 4. So let's put it here. 8 minus 4a divided by 4. 8 minus 3a divided by 4, my bad. 3a divided by 4. All right. So Terry plays basketball for 5 hours in the morning and 4 hours in the afternoon. He does this for a total of 30 days. At the end of the 30 days, he has a tournament and plays basketball for 15 more hours. Which numerical expression shows the total number of hours Terry played basketball? Okay, so Terry played basketball for 5 hours in the morning. So 5 plus 4. There we go. 5 plus 4 in the afternoon. And he does this for a total of 30 days. So that thing multiplied by 30. At the end of 30 days, he has a tournament and plays basketball 15 more hours. So plus 15. B is our answer. The tape diagram represents an equation. Find the value of f that makes the equation true. So f would be 19 minus 16. That is 3. The square the square below represents one whole. So the entire thing represents one whole. What percent is represented by the shaded area? So how many boxes are there in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's a 10 by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 by 10. So 100 squares, little squares. The square below represents if one whole, then how many shaded do we have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 61 is shaded. So how many percentage? 61%. Okay, so Abby knows that 1 mile is about 1.61 kilometers. She wants to write an equation she can use to convert any given distance in miles to kilometers. So how should Abby write her equation? She wants an equation to convert any in miles to kilometers. So how should she write? Okay, we know that 1 mile is 1.61, but her goal is to convert any given distance in miles to kilometers. So 1 mile would be 1.61 kilometers. So kilometer would be 1.61 mile. So which equation does this? This thing is the same thing as this thing. If we divide both sides with 1.61, 1.61, this gets cancelled out. So C is our answer. Oh, wait. Oh, it's the same thing. I didn't notice B as well. B was the exact same thing that I wrote. Yeah, so B makes sense even more. I think every equation uh, preserves the same thing. So if I make K subject here, okay, so 1.61 m. So I should have checked all the options. All of them is the same, but which one does because I wanna make the I want an equation dedicated for converting any given miles to kilometers. So I'm inserting miles. This is our dependent thing, and K is the independent. So we have to make K the subject set. That's why B is our equation. All right. Okay. So for this one, we have Francis can complete uh, 91 oil changes in 7 days. How many oil changes can Francis complete in 11 days? Okay, so let's figure it out in one day. In one day, 91 divided by 7 oil changes. So in 11 days, this will be this thing multiplied by 11. So 91 divided by 7 into 11, or 91 divided by 7. Sorry, 91 divided by 7 into 11. 143. 143. That's it. This is the end for our course challenge.